So the first thing is, for the rules of anti-differentiation, ignore the page number. This is from the second edition of the book. Actually, the page number in your book is page 285. So, first thing is, if you find the area under the curve from A to B of f of x, which is your height, times dx, which is your width, that's the opposite of the area if you went from B to X, if you went from right to left. Now, that's just some rule you're going to follow for now. After we do, by the time next week, we will show you why that works in terms of the picture and in terms of anti-differentiation. For now, you're just saying, okay, if I go from right to left, I get the opposite area. Which you will absolutely see that on the AP test. Next thing. This is 0. It should make sense to you. Why? Because if you go from A to A, you have no width. So the area under the curve would be 0. Does that make sense? You have this height, y, but you have no width. This constant multiplier can be moved out front of the integral. It's not a big deal. You can say, here I'm multiplying after I found the area. And here you're saying, if I multiply the height, it would be the same thing. You expand your height by a factor of k, the integral is saying the area of this height times the width. This one on the left is saying multiply your height by k. Multiply the area by k. This thing is saying find the area and then expand it by a factor of k. Same thing. If I had a rectangle that was 2 by 1, and I expand it by a factor of 3. So now the height is expanded by 3, it's 6 by 1. The area is 6. This is saying here's your 3 out here. The area of the rectangle is 2 by 1, it's 2, then multiply that by 3. Same thing. The integral of the sum is the sum of the integrals, as long as the limits are the same. And then what? Well, if you go from A to B, and then you pick up and go from B to C, that's the same thing as going from A to C. There's a visual explanation of this. And you got to pay attention to the upper and lower limits. So here is why 0.5 works. There's the area from A to B. Make sense? This thing that's shaded is saying, go from the lower limit A to B and multiply the height times the width. You get that area. Now you're going to go from B to C. That's the same thing as you just went from A to C. All right. The average value is what we're going to do tomorrow. Not really worried about that yet. We're going to spend today just on the rules. Okay? So here are the learning objectives. You need, ready? 2, 4, 6, 7 learning objectives. You need to look through that, see if that makes sense, that language makes sense. Images back on those two. And here's the question from the end. So like I said, we're not going to do average value to the beta lesson, but it's saying what's the average value of the cosine function from 1 to 5. So if this was, for BC, traditionally we've done this in one day. Under the circumstances, we're looking at the beta lesson. We'll let this go. So here's example 1. And this goes to the properties that were on the PowerPoint on page 285 of your book. Right? It tells you this. From -1 to 1, the area of the curve is 5. Well, you can draw a picture if you want. Say, okay, my picture looks like this. From -1 to 1, the base would be 2. If you got a rectangle, the height would be 5 halves. 2 times 5 halves will give you an area under here of 5 square units. That make sense? It does not have to be a rectangle. It could be any curve where that area is 1. Then from 1 to 4, the height times the width is a -2. So you're going to go from 1 over to 4. This area is a -2. So it has a width of 3. So it has the height of -2/3. And that's a -2. And then it says you have another function. This other function, h, so these are both f's. The other function has h of x, the height times the width is 7. So h comes in here, and that whole big area is 7. So your picture is not going to represent anything other than your image of this. You understand what's being asked. So A says, if I go for f, and I want the area from 4 to 1, that's the opposite because the limits are switched what you were given. The opposite of -2 is positive. And again, that's not going to make any sense to you yet. But by the end of the chapter, we're going to see how important that is. Reverse limits. B. -1 to 4 of f. Well, this one picks up the -1 and stops at 1. This one picks up without left off. So you just add these two. 5 is a -2 squared. C. -1 to 1. If the limits match, double f. Double f would be 10. Triple h. The limits match. Triple h. Who is triple h? Yes. Triple h would be 10 plus 21, that'd be 30. But now look, well, we got D, E, and F. So we go to the textbook. D wants 0 to 1 of F. Well, we knew, right? We knew that from -1 to 1, well, F was 5. They're asking from 0 to 1. Well, half of 5 would be 5 halves. Yes? But we don't know that F is symmetric. That was just symmetric in this picture that we drew to help us understand what's going on. So we can't do this. C, that takes H, and goes from -2 to 2. Well, negative 1 to 1, 7. So that has a width of 2. Negative 2 to 2 has a width of 4. Double 7 is 14. Can't do it. Nothing based on the information you're given. And F, negative 1 to 4, F plus H. We can do negative 1 to 4 of F, but we have no information about H from 1 to 4. When you look at this, A, B, and C, you can quantify D, E, and F to have right? So, that's your model, and you're going to problem number 1. Right, so for problem 1, based on the given information, none of those are ones you can't do. A, the figure has no width, you're going from 2 to 2. That'd be a 0. B, you're going from 5 to 1 for G, which is the opposite of going from 1 to 5. Number 3 is a size change from 1 to 2 of F. 3 times a negative 4 is a negative 12. Now, B's a little different. You can get a problem like B. Before, B says from 2 to 5 of F. Well, I know what 1 to 5 of F is. I know what 1 to 2 of F is. If I subtract that, you would have 6 subtract a negative 4, and you have 10. E, 1 to 5, you have to add these two. I'm sorry, you got this. 1 to 5 is given for F. 1 to 5 is given for G. You just subtract it with 2. And then F, same limits 1 to 5. 4 times F, 24, take away the 8, and 6. Okay. So that is it for all we're doing for the alpha lesson.